Hey everyone, welcome to the next session from Deep Dive Python session series presented by Trivandrum Python Community. Today we have Abdur-Rahmaan Janhangeer, a well-known name in the Python world, who will walk us through the internals of CPython on Android. Abdur-Rahmaan Janhangeer is an author. He is famous. He is famous for his work on books like SQLite Internals, which is a free and open source book exploring the internals of the SQLite database. He's also an organizer of Python Mauritius user group, and he's an open source contributor who contributed to open source projects with a combined user base of over 3 lakh users. Thanks for accepting our invite, Abdur-Rahmaan, and over to you for the session.
Okay, yes, thank you very much for having me. Well, this session will be about CPython on Android, which, I think maybe some of you know, maybe it's not well known, but CPython also works on Android. Like it has official support. So, a bit about me. Um, so, I'm from Mauritius, which is a very small slides so that you can later review the materials. And I'm one of the organizers of the Python Mauritius user group, which is pymug.com, PYMUG. This is a typo. Well, why I thought of talking about CPython with Android actually, because Android is still very. It doesn't have like official support. It has official support, but it's not like very. It's like a tier three. It has tier three maintenance, which means that the tests for Android won't be run on every um, CPython commit. So, well, it's there, but it definitely needs a lot more help because as we'll be seeing, CPython on Android is still in its very early stage, and hopefully, I have presented here will give us enough to get interested and get start to contribute. And my interest in Android began when I was I think forever I've been interested in Android because I think we all have like phones, but for the past like 6 months, I've been developing a React Native application and doing some really like nasty stuffs because React Native is you use React to write Android apps, but as you work, you get many different errors, sometimes even C++ errors and patches, etc. So this prompted me to really understand what's going on because let's say you know TypeScript, you know React, but what exactly is going on behind the scenes? So I wanted to dive more to understand because for example, one question that comes up, why React Native has like C++ code if you are just coding in React, which is a very nice question, which we'll also cover. For example, and thank you to to the Trivandrum Python community for having me, which I don't know. It was in Kerala until recently, because I visited Kerala in January. Yeah, so, but yeah. So Let me say, like, if ever you've taken operating system courses and you study Android, you will see that Android is a great, it's an amazing operating system because everything is very well defined. Let's say you take, for example, Linux, or for example Ubuntu. So you have the experience is up to the user. But on Android, everything is very well defined. How apps should be, what standard they should be respecting, and how the app should be, for example, sign and etc. 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 It's you have a great experience, and also in terms of security, it's very secure. For example, you have like you, for example, the boot sequence verifies a lot of things. You have like managing biometric, like your fingerprint, etc., biometric data, etc. So it's a great operating system. The way the whole experience is designed, like it doesn't stop just at the kernel level. Okay, you have an operating system and it's over. And it's really very interesting if you study it as an operating system. And why is Python decided? Well, maybe it's worth seeing what's happening Android has a lot of market share across all operating system, apparently, which I don't know if Wikipedia is very trusted, but I saw another presentation where they were saying like it represents 42% of all like operating systems. Here I see 34.9%. So, but definitely it's not something like negligible. It's something that is present. Yes, and yeah, and a bit about how Android works. Well, you have those different layers. Well, you have your phone, and then you have the operating system, and then you have the hardware abstraction layer, which essentially just provides a unified access to any sensor that you might want. And then you have the native libraries, which because the Linux kernel doesn't have like the rendering engine for Android, for example. So the developers have to write a bunch of different, for example, how to handle media, etc. So they have their own like idea of it. So they wrote the code in C, in C++, all those things. But they also like allow you to use to write C++ code that can be called in your app. If you are coding in Java, if you're coding in Kotlin, for example, you can write C++ code and then you call it from Kotlin, which is the same thing for React Native, for example. You can have custom C++ code and you call it in React, and you get like well, the problem is you have at some level you have the layer that provides Android's different components like activity window, etc., like all the concepts that you know about. And then you have the apps layer. So this is how like Android works. It's a very constrained system. It tries more and more to restrict the scope of apps as free to as for example your PC. It's a very like constrained environment. And yes, so this is how like Android works. The GNI that you see, the uh, the native interface allows you essentially to write your whatever code in Java and you call like C++ code. Yeah. So yes, coding wise, it's really very simple. You just pass the C++ function in a special function, and then you call it, and you get the result. It's very simple. results, or you do the action that you want. Really, it's coding wise, it's conceptually simple. And let's see, for example, CPython on the desktop, how it works. So you have the source, which is in C, and then you have a C compiler that takes the CPython source and compiles it into a binary. And then you have your Python source files, which the binary then executes, and then you have your output, your action, etc. But in the case for Android, how CPython does it now is that you have the source, the CPython source, but you have the Android compiler. You have a compiler. It uses the Android compiler, which is very standard across all development that you would do for Android, and then it compiles it into a library, a shared library. It's lib python version.so. The .so file is a bit like this, and then CPython will take that .so file, it will put it into an Android app, and then well, and then what happens we'll discover next. So since CPython for Android, it's not like on the desktop, it's actually inside an app. So naturally, we will expect that in the Android operating system, it will be at the like this, but just you understand that it's an Android app. It's like any Android app on an Android device. So what is in a .so file? Well, it has the different components of the CPython of CPython. For example, if you know a bit how CPython works, you have, for example, the parser. You have, for example, the virtual machine that executes the bytecodes. You have the pod that produces the bytecode, etc., etc. Everything just sits inside the python.so. It doesn't do anything. And then you have, like, for example, you have functions, for example, by initialize, which is also there, but at this point, it's still doing nothing. It just bundled into the Android app. But when the app is run, so the linker will take the shared library and put it in memory, and then the app, the Java code or the Kotlin code will call the GNI. Well, it just code wise, it doesn't do like, it's not much, it's not very difficult, but conceptually speaking, it will, like, the through the GNI, it will call a C function, which is by initialize. So Java calling C, you would use Java has called that C function. What happens then? Python spins up. The Python interpreter is loaded. Whatever it needs to run is loaded. At this point, it happens, and then inside that Android app in that you would run on your mobile to run your Python files. What it does, well, what it has essentially, you have like python.so, which has like functions, which has the CPython components. You have the standard library, which is zipped and put inside the APK. You have the source files, which you wrote, and then you have like code to get the app going, like code in Kotlin or Java. Um, so from what we can see, since like Python is inside an Android app, as like an app in itself. So Python runs inside an Android app. It this is what we mean by runs in embedded mode, or Python is embedded in that Android app. So which also means that it is the app that controls when to start Python and to end, which also means that whatever code you write, so Python decides when to start it and when to end it, but it's also subject to the app. So this also means that your Python app will also shut down. So yeah, and if you go to the CPython source, you will get this app that we were talking about, the Android app that CPython compiles, the like CPython compiles, and you can use it on your mobile phone. So if you open the CPython source code, you go to platforms, Android, testbed, you will get the app from there. And if you read the README, it will give you instructions on how to run the SO. So if you go to the README of like Android here, it will give you the instructions on what to run, on how to build the .so file, and how to build the APK so that you can run it on your phone along with other Python code that you have. So what happens when you run CPython on Android? So it appears as an app, which when you click will run what is in main activity.kt.kotlin, and then main activity will spin Python and will make Python run whatever code you have written. And main activity.kt, it's here, Android testbed app source main, etc. So you see where it is. And Python for Android, Python releases for Android. So either, for example, you go to platforms, Android, then you follow then you compile it from there, or you can just follow the instructions when downloading this these releases. So when you download the file, it will look like this. So, and then the Python code that you have to write, so you put it inside src main, so you can write your code, which yeah. So as you see, it is maybe not what you expected, and the look of it is still looks like very like not very friendly. It doesn't have a very friendly like experience. That's why we need more people to like understand and try to help a bit. And for me, I also wanted like to write Python apps, but I wanted you write Python, and then you you just have to, because one problem with current CPython currently on Android is that it doesn't have a way to include GUI. to include GUI. You have other projects like I think ChacoPy, you have Beware, etc. that does it. But CPython, as such, as we have covered until now, it doesn't have a way to generate like to open an interface. So this is why, well, this is just an experiment. Like I wanted to bring the React Native experience to Python, which is like you just write your Python code, including GUI, and your app runs on an emulator wherever. So this is just a weekend experiment. You can check it out on my GitHub. So yes, so as you can see, you put your column, text, or button or whatever, and then you can like vibrate for 100 millisecond, which is very nice because this demo shows that you can like write uh you can write user interface and also access the sensors. Oh, yes, and also worth noting like how the landscape looks like outside of CPython. You have projects like Kiwi and Beware, which provide what you need to, which are more advanced than CPython at this point. So, what, one interesting thing is the Beware maintainers. They are the people who are currently maintaining and overseeing how Python works on Android, and they are trying to port their experience with Beware to CPython. Beware is a collection of projects that allows you to run your Python code on Android. It has, for example, Toga, which compiles Python to Android UI elements like TextView or whatever. It also provides all the necessary tooling to seamlessly um, build an APK. So yeah, so I guess my experience they have been in Beware, it will make its way in C. The question is whether they will use a custom rendering engine or whether users will be able to Android code. Like for example, if you are using TextView in Python, it is the same TextView that Android users that you will get. Well, there are many different questions, and of course you have Kiwi. Kiwi it just uses it has its own rendering engine. So, but like for example, even Beware, even Kiwi, the experience is a bit like rough. I don't say that like React Native is not rough, but this is rougher. And CPython has a lot to catch up to be able to write like proper Android codes. So yes, this concludes my session for today. And in the 5 remaining minutes, if you have any questions, I'd be happy to take them.
Yeah, I think we currently do not have any questions from the attendees. So, yeah. So I think,
Okay.
yeah, we can.
So, well,
Yeah, please go ahead.
yes. So I think the thing with this session is I hope that people who are looking into CPython and Android, so maybe they will pick the interest will be peaked and they will be motivated to like dig in further and help CPython with a very nice integration. Yes. Yes, I think that's all from me.
Yeah, okay. Thanks, Abdur-Rahmaan. Thanks for the session once more, and thanks for accepting the invite from Trivandrum Python Community. So yeah, it was an awesome session, and
Excellent.
during my college days, I developed a few Android apps. It was back in Java days before Kotlin. So this makes me want to try building an app using Python. So I was not very much aware of this Python and Android landscape. Yeah, thanks for the session. And if you plan to visit Kerala once more, we would love to host you. Thank you. And thanks everyone for tuning into the session.
Yes, definitely.
Yeah, sure. Thank you. See you at the next session.
Yes.
Bye.